Hello and thanks for checking out this video on the new Team Render in Cinema 4D R15. So Team Render is a very exciting new addition to Cinema because it allows you to do network rendering directly inside Cinema 4D, and it also allows you to do painless single image rendering, which always was very tricky to do previously. So let's dive straight in. First of all, I'm going to show you a single image example and then an animation example. So I already rendered an image here with the standard renderer, or at least with the regular picture viewer render using the physical renderer, and that took 4 minutes 38 seconds. So let's go into the Team Render menu, and we basically have two important additions here. We have the Team Render to Picture Viewer and we have the Team Render machines. So let's open up our machines first. That brings up an overview of all the machines active in Team Render. So you have your local machine, which is the one you're working on, and then you have, in my example, 4 external machines. Now, I'm sure that not everybody has this amount of computers lying around, but I think most people will have maybe their old workstation somewhere in the corner, and even that can give you a nice speed advantage of maybe about 50%. So it's not necessary to have a very big list here. So I have these extra systems, and this should give me a speed bump of about 300%, so about 3 times faster, because some of those systems are old. And well, let's render this. So just go to Render, Team Render to Picture Viewer, or find it here as well. And let's look at what happens. So at the moment, Team Render is distributing the files over the network. So of course it takes a few seconds before you will see a start, because it needs to send it to each one of those systems. And there we go. So you have 2 buckets for each system because I'm using the physical renderer. So we see around 10 buckets. Sometimes you see more or less because of the updating. And the buckets are dynamically distributed. So basically, if you would at the start say, okay, this system renders those buckets, then the slower systems are not going to be fast enough. So they didn't dynamically ask for a new bucket every time they finish one. So you have a very nice progression, and you don't have those empty buckets sitting there for a very long time. Right, so we're about halfway, and if we go back to the render time here, let's have a look. So 4:38. So we're going to see a speed improvement of around 3 times, but a little less because of those additional efforts that Team Render has to do. So the distribution of the files, that takes a few extra seconds, and then the distribution of the buckets always takes a little bit of communication between the server and the clients. So that's why you won't see a the full advantage of that extra speed, but it's quite close. So here we go. And we're at 141, so a little less than 3 times faster. And of course the image looks the same. So one of the advantages is that it's a very flexible system. You don't have to worry about setting up your file. It just works out of the box. So there you go. That's the single image renderer. Now let's close this and go to an animation. So I have an animation here. I already baked the cloth sims, and I set up the frame range. So let's dive straight in and team render this. I don't want to save this. And well, you see that all the frames are already present from the start. So frames 20 to 100. And once one of those frames is finished, it will automatically update here and also in your view. So what's happening right now is Team Render is distributing which frame will be rendered by which computer. And it's doing that in a very useful way. It's basically dividing these 80 frames into 5 sections. So the first section is 22, I think, 36. And then the second section starts at frame 37. So the advantage is that you quickly get frames all over the animation. So one at the beginning, one at the end, one in the middle. And that's very useful because often you discover an error halfway in animation. So the first few seconds may be fine, and then at the end there's some strange error because you forgot to turn something on or off. And you have to render it again, or you have to sort of blend frames. And so this is a very good way of checking the quality. We have 2 frames here that are already finished. So there we go, 84 and 68. And when you just click on one of those empty frames that hasn't been rendered yet, it will automatically update the next frame again and again. So if you just don't touch it, it will always show the most recent finished frame. So at the moment I'm waiting for those slower systems to also finish some frames. There we go. So now we already have the first frame. We also have frame 36 here. So we quickly have a view of the entire animation. We can spot errors. Of course, there can also be errors in the movement. That's something you can only spot when you have multiple frames. But this is usually one of the issues I especially discovered a lot when rendering animations. So that's a very nice workflow. And I'll just speed this up. There we go. And that's the finished animation. So I'm sure you'll see that this is very useful, especially for test rendering. And eventually test rendering is what you'll usually be doing. Most of your renders are test renders. There's only one final render for each project. So this kind of very fast integrated workflow can really speed things up. So I'm sure people have loads of questions. A few important things I want to add. First of all, I rendered this in the picture viewer. You can also use the render queue, obviously, and that's a little bit better because you have a few more options there. For example, pausing and resuming renders is also possible. So I would advise to use the picture viewer for quick renders, so anything under maybe 1 or 2 hours. And for the longer renders, use the render queue. Then there's also caching. So we have global nation caches and SSS caches when you're rendering. And for all these caches, you have a checkbox, whether you want them to be computed in Team Render or on your local machine. And this is quite useful because sometimes a cache can be computed quite fast. So for example, just in a few seconds. And then it would take more time to send the files over Team Render, start the caching, communicate between the systems, etc. So if you know, okay, this cache is just really quick anyway, then just only render it on your local system. And if it's a heavy cache, then you can use a Team Render and you'll see an advantage. Alright, that's it for now. I hope you enjoyed this tutorial or this video, and stay tuned for more updates on R15.